Hi, Level 3s. Welcome to Lesson 9 on alcohol reactions and alcohol properties. So, let's just jump on into it. So, you've done some of these last year, which is really cool. So, the first the four types of reactions of alcohol are combustion, oxidation, substitution, and elimination. Now, luckily, you've done combustion before, and you learn about combustion at level 1 when you do carbon 1.3. The fact that you can combust alcohols, they generally completely combust, which means they produce water and carbon dioxide. Oxidation, you also did a little bit of at level 2, where you oxidized a primary alcohol to form a carboxylic acid. I briefly showed you at the start of the topic when we learnt about at naming aldehydes and ketones that actually you can also form an aldehyde from oxidizing a primary alcohol, and it becomes the intermediate step before making a carboxylic acid. You can also oxidize a secondary alcohol to form a ketone, so that's how ketones are made, and so we're going to run through that. Substitution reactions is where you replace the OH functional group with another functional group, and that's your Sockles and Pickles. Hopefully you remember those from last year, so we'll go through that again. And elimination you also did last year. So mostly, to be honest, this is recap of level 2. Okay, so combustion here. So we can combust alcohols, and they usually burn really well, and so you produce carbon dioxide and water. Remember, I've told you that I really don't want you to be doing half ratios in terms of, doubling the equation here, so making that 2 ethanols. Just keep it as 1 because we'll end up doing combustion when we get to 3.4. So we can combust ethanol with oxygen to form CO2 and water. Easy peasy, I'm not going to go through that anymore. Balance your carbons first, then balance your hydrogens, and then balance your oxygens last. The reason for that is the fact that the oxygen is by itself, so it just makes balancing easier. Okay, next. So oxidation of alcohols. So we can only oxidize your primary and secondary alcohols. When they get oxidized, you may not have realized, but and I'm actually going to flip to the next slide to show you, and then we can go back. When you oxidize an alcohol, what actually happens is a double bond is created. So you can see here, this is a primary alcohol, propan-1-ol. When it gets oxidized, it can actually now, this is a new step, form propanal, and can also then further oxidize to form propanoic acid. So you can see here that you've got a C double bond O formed, and then in this next bit here, to form propanoic acid, another oxygen's bond been bonded. What's really cool here is that when we learnt about oxidation in the redox topic, that oxidation is the addition of O. Apologies for my crappy writing here. I've forgotten my pen, so I'm trying to do this with my pad. So you can either add O or you can remove hydrogen. So those are two ways that we can visually see oxidation happening, and that's a really important skill, and that's what I kept trying to remind you of when we learnt redox. If we look here, you've got propan-1-ol and it's forming propanal. So what's happening in this first step is that we're actually losing a hydrogen. So this hydrogen's going and we're getting a double bond O. So that's a sign of oxidation. In the next step, the propanal is getting oxidized to propanoic acid, and you can see the addition of an oxygen, okay, which means that this is in fact oxidation in this next step here. So it's important that you visually can see those steps happening. So your primary alcohols can get oxidized, as we've said, to an aldehyde or a carboxylic acid. And what's really handy here is they use the same reagents that we learnt last year. So last year when you oxidized your propan-1-ol, because remember last year you did propan-1-ol and you went straight to propanoic acid without the aldehyde. And so last year you used Cr2, I'm not even going to try, Cr2072- /H+, so acidified dichromate, or the alternative is acidified permanganate. Now, we've just done redox, so you guys are brilliant with these colour changes. The dichromate, okay, the Cr2072- is orange in colour, and it forms your Cr3 plus, which is green. So you need to know those colour changes because qualitative data is just important as anything else, so you do need to make sure you know those for this assessment. The alternative reagent is the acidified permanganate, MnO4-, which is purple, and it goes to Mn2+, which is colourless. Apologies that these colours seem to have slid over a little bit there. So those are the reagents that we need to know, and now you've learnt the oxidation of primary alcohols. The next one is the oxidation of a secondary alcohol to form a ketone. This is completely new because you didn't know about ketones last year. Remember, in ketones, their functional group, the C double bond O, the carbonyl group, is in the middle of a structure. For propanone or butanone, you don't actually have to put the number here, the propan-2-one. That's optional. However, I reckon it's good practice just to chuck it on in there. You won't get marked down. So this is propan-2-one here, and it's formed from the oxidation of a secondary alcohol. Secondary alcohol, because the carbon that the OH is attached to two other carbons. And back up here we could say this was a primary alcohol because the carbon with the OH is attached to one other carbon. Okay, so that's the oxidation of a secondary alcohol to form a ketone. And these use exactly the same reagents as the primary alcohol, so acidified dichromate and acidified permanganate, which is brilliant. So you guys did get introduced to this when we did naming, but this is a really, really critical reaction for you this year. Fabulous. Okay, so we're going to move on now because actually before we do, I might mention one other thing. We've spoken every time we've done functional groups about their intermolecular forces. So I want to quickly talk to you about the intermolecular forces of these substances here. So I'm just going to get my pen back. If you look here, propan-1-ol has got this OH group here. Now, because it's got this OH group here, it means that this molecule can in fact hydrogen bond to a neighboring molecule, okay? So propan-1-ol has got H bonding, it's got permanent dipoles, and it's got temporary dipoles because it's got electrons moving around. So I'm going to repeat that again. Propan-1-ol has got H bonding because it's got this O bonded to this H, which means that this makes this really super strong dipole. So this electropositive hydrogen is going to attract to electronegative oxygen in a neighboring molecule. Remember, we were talking about intermolecular forces, and so this molecule has H bonding as a type of intermolecular force. Now, anything that's got H bonding also has permanent dipoles because it has to have it has to be polar if it's got H bonding. So this has also got permanent dipoles between the molecules here, and because it's got electrons like every other molecule, it's got temporary dipoles. So it's got all three intermolecular forces, meaning that propan-1-ol has a relatively high boiling point. We're now going to jump to propanoic acid. So propanoic acid here also has this beautiful OH group here. So you should be thinking, oh, well, this also has hydrogen bonding. And remember, this isn't the hydrogen bond, the O to the H. It must have this covalent bond present, but that is not the hydrogen bond. The hydrogen bond is the attraction that this molecule has for a neighboring molecule because of this super strong dipole that's created from this double bond. So this also has got hydrogen bonding. Now, because it's also polar, it's going to have permanent dipoles, and because it's got electrons like all molecules, it's going to have temporary dipoles. So you should be thinking, okay, cool, propanoic acid and propan-1-ol have got all three types of intermolecular forces, so both of these molecules will have relatively high melting and boiling points. So then if we look here, propanol. Now, what does propanol not have that the other two have? And it's this really significant no oxygen here bonded to the H, which means propanol has no hydrogen bonding. Now, this is really, 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 really important because that means that it's only got permanent dipoles and temporary dipoles, meaning that propanol will have a significantly lower melting and boiling point compared to propan-1-ol and propanoic acid, and that plays a really significant role in the rest of the lesson. So I'm just going to repeat that one more time to make sure we're all on the same page. Propan-1-ol and propanoic acid, because of these OH groups, can actually have hydrogen bonding, permanent dipoles and temporary dipoles as intermolecular forces between their molecules. And this means that they take quite a bit of energy to break, and so they've both got relatively high melting and boiling points. In contrast, propanol does not have the O bonded to the H here, so it cannot hydrogen bond as an intermolecular force. It's only got permanent dipoles and temporary dipoles, meaning that its melting point and boiling point will be significantly lower than its corresponding primary alcohol that it was made from and its corresponding carboxylic acid that it could get oxidized to. Okay, so let's move on. So we've spoken about the fact that that a primary alcohol makes an aldehyde and then a carboxylic acid. So something you need to be aware of is this: if we were to do this in a boiling tube in the lab, so we have some ethanol and we chuck in some acidified dichromate, which is orange, and we put it in a water bath and we heat it up, it will form aldehyde and it will further get oxidized and it'll form the carboxylic acid. The tricky part is you would have some aldehyde present and some carboxylic acid present. So it would be a mixture, which, yeah, that's cool, that's fine, but sometimes you don't want a mixture. Sometimes you actually just want a beaker of ethanol. Well, not actually anymore, because you're not allowed aldehydes in the lab because they're too dangerous. But anywho, if you wanted to, you could make it, and if you wanted to, you could make your carboxylic acid. So, and that's what I'm going to talk to you guys about today. Now, you can see here, this is also reinforcing. I've never seen a question that really says why is this classed as oxidation, but you guys would be able to classify. Here's ethanol going to ethanal, and you can see the removal of hydrogen is justification that it's oxidation, and in this step here to the carboxylic acid, oxygen is added, which is justification for oxidation. And here we can see, here's your secondary alcohol, your propan-2-ol. It's removing two hydrogens to form propanone. It's the same thing. Okay, so let's now talk about making these molecules. So we can, as we've said before, we can make your aldehydes and your carboxylic acids from primary alcohols, and you make your ketones from secondary. In your exam, you are going to be asked about how this is practically done in the laboratory. So you need to know the difference between distillation and reflux. So the key thing is that an aldehyde is made by distillation, and ketones and carboxylic acids are made by reflux, and I'm going to run you through that now. Now, if I was in the lab with you, I would have this glassware out, but I'm not, so you'll just have to wait for the glassware in real life till when I'm back. So this is the setup for distillation. Now, hopefully distillation, that concept is not a new one to you. You learnt it in Carbon 1.3 when you talked about fractional distillation of oils. Remember the black oil from the ground, and we separated out into useful carbon fractions based on their boiling point. The same principle applies here. So this is the way to make an aldehyde, and hopefully you're starting to, or some alarm bells will be going, oh, Miss Sutton just spent ages talking to me back here about the fact that the aldehyde has a lower melting and boiling point compared to propan-1-ol and propanoic acid, and the significance of that is now. So the only way to make an aldehyde so that you ensure you don't have any carboxylic acid, which it can further get oxidized to, or to ensure that you don't have any unreacted primary alcohol, is to do distillation. So how do we do distillation? You chuck your reagents into this round bottom flask. So let's say we want to make butanal. So what we would do is add butan-1-ol here and some acidified dichromate, and we would heat it. Now the critical part here is that we want to heat the mixture to just above the boiling point of our aldehyde, but lower than the boiling point of the primary alcohol that made it, in this case butan-1-ol, and the corresponding boiling point of the carboxylic acid, which in this case would be butanoic acid. So you'd put your butan-1-ol in here, and you would heat it to just above the boiling point of butanal. So what happens then is the reaction happens because we're heating it, and the heat speeds up the rate of the reaction, as we know, but we don't heat it strongly. So we heat it, but we heat it just above the boiling point of the aldehyde. So the aldehyde that's made is going to turn into a gas because it's slightly above its boiling point, and it's going to come up here. Now what this is here is, this part here is known as a condenser, and a condenser is made up of there's a tube of glass in here, which you can see, and that connects up here, and on the outside is another layer of glass, and what we do is we plug this into the tap, okay, water in the bottom and out the top, and the water out the top just goes into the sink, and what that does is that rushes cold water around this glass tube, and so what that does is that cools this inner glass tube down, and so that means that this hot gas that's produced up here hits this cold glass and condenses back into a liquid, and so that aldehyde's going to go boop, 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 and we can collect the aldehyde down here. So this is a wonderful piece of chemistry. Now I have to stop this video and I have to make another one because I've only got 15 minutes each time. The next video will be nice and short to finish off the lesson. So I'll see you again soon.